Greetings everyone, my name is Shashank Bagda and today I am here to simulate on the topic Transistorise Astable Multivibrator. So, in this documentation, we will cover the working principle, the theoretical knowledge and understanding components and circuit diagram, while in simulation, we will see the placing of the component, making of the requirement circuit and observing the output waveform and conclusion. So, the very firstly we have to learn the circuit arrangement and placing of the component. So, in this circuit, we need to understand the component used in it. There are four resistor, two capacitor, and two transistor. So, first will learn about resistor. A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow and adjust signal levels, to divide voltages, bias active elements and terminate transmission lines, among other uses. Now we'll see about capacitors. So, the most common use for capacitors is energy storage. Additional uses include power conditioning, signal coupling and decoupling, electronic noise filtering, and remote sensing. Because of its varied application, capacitors are used in a wide range of industries and have become a vital part of the everyday life. Now, the second thing is transistor. Transistors are commonly used in digital circuits as electronic switches, which can be either in on or off state. Both high power applications such as switch mode power supplies and for low power applications such as logic gates. Now DC supply is just a DC power source of which is needed to operate and power up the circuit. Without power supply there is no mean of this circuit. This is DC, it means direct current power supply, so we need to take care about the positive and negative of terminal of it. We should join the negative supply with the ground and the positive with the current input. Now moving ahead to the construction of the circuit, we should know the theoretical concept of the circuit. So there are so many questions in our mind, like what is multivibrator, what is astable, and so on. So very first concept we will learn is what is astable multivibrator. Astable multivibrator does not remain stable in one state, and the output of the multivibrator continuously changes between two states. This type of multivibrator is used in the design of a relaxation oscillator, the duration for which a stable multivibrator remains linear can be controlled by passive elements like the resistor and capacitor. At the end, the expression of the frequency is derived. Now, the second thing is the arrangement of the astable multivibrator circuit. So here in this circuit, as you can see, it consists two transistors, Q1 and Q2. Here Q1 is the first transistor and Q2 is the second transistor. As we can see, both of them are cross coupled with each other via capacitor. Now let's check the working of the circuit. Before that we should know that how the transistor is used as switch. When the input voltage are less than 0.7 volt, the transistor will operate in the cutoff region, which means it will behave as an open circuit, and hence VC is equals to VCC. Similarly, when the input at the base is high, then the transistor will operate in the saturation region, which means it will behave as short circuit, and hence VCE is equals to 0. The reason behind knowing the working of the transistor and switch is because we will replace the transistor in the circuit with a switch. So initially, when there is no power supply given to the circuit, then both transistors will be in cutoff region. When we apply the power supply, then both transistors will try to conduct. Now one more thing to notice over here is that the value of the collector resistor is smaller than the base resistor. So as soon as we apply the supply voltage, the capacitor will charge through the low resistor, but due to mismatching of both circuits, one transistor will conduct more than other transistor. So due to that, only one transistor will go in the saturation region first. Let us assume Q1 goes in the saturation first, so the collector emitter terminal of the transistor will act as a short circuit. Now, to up to this point, when transistor Q2 was conducting, then some charge got accumulated across the capacitor. Due to that, the voltage across this capacitor C1 is equals to Vc1. Now as soon as the transistor Q1 is short circuit, one end of the capacitor is grounded. And due to that, voltage minus Vc1 will appear across the transistor Q2 and it will go in the cutoff region. So this is the first state of the astable vibrator, in which the voltage at the collector of the Q1 is 0 volt and the voltage at the Q2 is equals to Vcc, and hence one transistor Q1 is on and second is off. Now the second state of the circuit is, let's say the capacitor Q1 is charging through the base resistor RB2. As is charging from RB2, the circuit C1 reverse charges. On the other end, the capacitor C2 will charge through the RC2. Now if you notice, the transistor Q1 is in the on condition, so the base emitter junction of the transistor will be forward biased. Now on the other end, capacitor C1 starts charging towards the voltage Vcc. As soon as the voltage at C1 is equivalent to 0.7 volt, the transistor Q1 will be activated and conduction will be started, and eventually it will go into the saturation, and hence transistor Q2 will act as a short circuit. Meanwhile, the capacitor C2 is also charged up to the voltage Vcc minus Vbe. Now as the transistor Q2 is short circuited, the right hand side of the capacitor C2 is grounded. Now as the capacitor C2 is grounded, the voltage applied to the base of the transistor Q1 will be equal to minus of Vcc minus Vbe. Due to this negative voltage, transistor Q1 will be turned off. That means now the transistor Q1 is off and the transistor Q2 is on, and hence the second state of the astable multivibrator. Now moving further to the third state. So in this condition, when Q1 is off and Q2 is on, the capacitor C2 charges in the reverse direction through RB1, while on the other end the capacitor C2 charges through the resistor RC1. As soon as the capacitor C2 charges up to the 0.7 volt, then the transistor Q1 will start conducting, because the voltage at C2 will directly appear at the base of transistor. So eventually it will go into saturation, or we can say that the transistor Q1 will be short circuit. Up to this point, the capacitor C1 has charged up to the voltage Vcc minus Vbe. As Q1 is now short circuited, the left hand side of the capacitor C1 is now grounded. So we can say that the voltage minus of Vcc minus Vbe will appear at the base of the transistor Q2. So due to this negative voltage, Q2 will turn off. So in this way, the state of multivibrator has changed once again. That means now the Q1 is on and Q2 is off. So in this way, the output of the astable multivibrator changes from high to low and low to high, and thus the cycle remains continuous. Now let's take a look to the simulation part. So this is the circuit of the astable multivibrator, and here is the graph of the output. So let's do this circuit. Now, as we discussed earlier, that to making of the circuit we need 4 resistor, 2 capacitor and 2 transistor. So let's do this. Firstly, we'll take 4 resistor, then we'll take 2 capacitor, then we'll take 2 LEDs, then we'll take 2 transistors, and 1 power supply and 1 ground. So now do this circuit. Firstly, we'll connect all 4 resistors with the power supply. Now we'll place 2 capacitor, one here and another here. Now transistor, now connect all 4 resistors with the positive terminal of the power supply. Now we'll ground the negative terminal of the power supply. Now connect the emitter of both the transistors with the ground. Now let's rename all 4 transistors with one is RC1, this one is RC2, this one is RB1, this one is RB2. Okay. Now connect RC1 with this LED and RC2 with LED2, and connect this LED2 with capacitor 2 and LED1 with capacitor 1. Now connect the collector of Q1 with this terminal and collector of Q2 with this terminal. Now connect RB1 with capacitor 2 and RB2 with capacitor 1. Now we have to connect base of Q1 is capacitor 2 and base of Q2 is capacitor 1. Now everything is perfect. Let's simulate. So as you can see, both the LEDs are blinking simultaneously. Once the LED 1 is on, the LED 2 is off, and when the LED 2 is on, LED 1 is off. Now let's check the graph. So here, as we learned earlier, that the astable multivibrator is those whose current are not stable in any one state, either high or low. They are continuously changing from high to low and low to high. So here you can see the output of from the oscilloscope of the astable multivibrator circuit, which is continuously changing from high to low and low to high. So thank you for watching my video. Have a great day.